Hello friends! It turned out that the review of the oscilloscope HANTEK 2D42 became one of the most popular videos on my channel. Maybe the reason of it is that the video was the first review of the oscilloscope HANTEK 2D42 on YouTube in English. So this video will be the first review in English of new oscilloscope DSO1511E of SigPeak company. The device is tiny and lightweight, it has the sampling rate of 500 megasamples and can measure the frequency up to 120 MHz. The device comes in a cardboard box together with a professional probe P6100, USB cable, the holder, which you can stick to the rear panel, and two additional probes for the signal generator, and also the manual. As for the signal generator, it can provide the square waveform up to 2 MHz frequency. But according to the supplier's information, the subsequent firmware will allow to achieve the frequency of the signal generator up to 30 MHz. First of all, let's measure the dimensions and the weight of the device. 10.5 centimeters, 7.3 centimeters, 3 centimeters, 163 grams. Now let's disassemble the device and see its circuit board. I have already removed 3 screws. Input connector, signal generator connectors, we can see even the version 6.2. As to the battery, here we have no inscription and it's too hard to remove the battery. That's why I used the capacity checker, and according to the measurement, the real capacity of the battery amounts to 1856 mAh. About the charging, here we have the micro USB socket, and as soon as we turn the charger on, the light emitting diode is on. As soon as the device is charged, it turns off. Long press, SigPeak, now the device is on. Power on X key button, run stop button, OK auto button, seconds and nanoseconds. Well, this is increase and decrease. Volts, millivolts, also vertical increase and decrease, and the menu. Let's see the menu. Channel 1, and here we have only channel 1. Coupling DC, AC. We can select it with the help of this button. AC, DC. In order to move to this function, we should use the right arrow. And also here we move with the help of this OK button. 1x, 10x, 100x. Let it be 1x. In order to move to the second section, we should use the up arrow. So now only frequency, peak to peak, duty, amplitude and period are displayed. If you need more functions to be displayed, you should move to the corresponding square and press OK button. Right arrow, right arrow, right arrow, right arrow, OK, or deselect, OK, OK. And in order to display all the functions, we move to this square, all. Menu, and here we see all the data. But basically we will need the following data. So frequency, amplitude, period, peak to peak and duty will be enough. The next section, trigger, up. And here we have trigger mode, auto, normal. If you need normal, if not, go back and select. Also trigger type and trigger level. The next section, display, persist, none, 1 second, infinity. So this is the delay of the graph. You can select 1 second or infinity. Let it be none. Also roll, on and off, and also the brightness of the display. Minus, plus. Let it be less. Next section, calibration, OK. And here we have the inscription, remove the probe first, please. FFT, a very useful function. This is fast Fourier transform. Log type, we can see. Also linear. And also designed for music. And the device may be really useful also for musicians. Let it be off. And the last section, set. Auto shutdown on and off with the help of OK. Sounds on and off. By default it's on. So but as for me it's annoying. Off. And also the language. Chinese and English. Now let's check the device with the help of its own signal generator. Minus, plus, auto, and this is because the probe is set to 1x. In case of high frequency, it's necessary to switch it to 10x. Let's increase. And now it's more or less okay. Let's use AC coupling. Menu. AC coupling. So how to change the frequency? Run stop, long press, and here we have the frequency, duty cycle, hertz, kilohertz, megahertz. Let it be 1.5 kilohertz. Okay. Seconds, nanoseconds. We don't need to increase, we need to decrease. Also, we can change. Let it be 20 kilohertz. $20 kilohertz. Okay. Auto. Here we have the voltage 290,289, but in millivolts. As to the voltage of this output, it amounts to 3 volts. But in order to get the real value, we should switch the device to 10x. Menu. 10x. Here we have the voltage, 2.9 volts. The peak-to-peak voltage also is almost the same, 2.9, even 3.02 volts, 3.00 volts. Frequency is 20 kHz, period is 50 microseconds, and duty cycle is 50%. Let's increase the frequency once again, 550 kHz. Okay, and now let's adjust the device manually. Not bad. Also, we can move the graph, which is really very useful. Left and right. It's also great. Voltage 2.97, peak to peak 2.98, 2.96, even 3.00 volts. The frequency amounts to 550, 549 kHz, not bad. The period amounts to 1.81 microseconds. Duty cycle is 50% or 49 and 9. Now let's go to the menu. One second. Okay. Let's change the frequency. (800 kHz), okay. And we could see 1 second delay. Menu, infinity. Frequency generator. Okay, and here we see the first graph and the second one at the same time. Menu, persist, none. Also, we can save this graph. X key, sorry, because it was long press. Save. Okay, save done. How to see this graph? View, and we can see this graph or even send it to the PC. As to PC connection, we should press menu, go to the last section, set, and long press nanoseconds. And now the oscilloscope is ready to be connected to your PC with the help of the USB cable. And the size of the files is 226 kilobytes. Also, we have another useful function. Reference. Okay, we can move this graph. And here is the old graph. And in case we change the frequency, we can compare the old red graph with the current yellow one. Now about the minimum and maximum. (1x), okay. So here we have limit 10 volts per division and the minimum 100 millivolts, 50 millivolts, 20 millivolts, 10 millivolts. Now this is the limit. As for the time, to 5 seconds, 10 seconds. 10 seconds is the upper limit. And 10 nanoseconds is the lower limit. And one more useful function of this device. You have no need of any transformer in case of measurement of dangerous voltages. Menu, 10x, now let's see the waveform of this voltage. Let's unplug the cable. Hope everything will be okay. It's great. Limit. We have the mains voltage, and that's why this mountain is a bit flat. So the waveform check without any additional special device is really great. Unfortunately, at the present moment I have no HANTEK 2D42, or the signal generator of which could help me to check this device thoroughly, but as you can learn from its review, the link is in the description of this video, the square waveform is dancing in case of the frequency more than 2 MHz. So there is no need of gearing of additional HANTEK 2D42, especially because the signal generator of this device can provide 2 MHz signal. Also, we have seen the sinusoidal signal now. I have no the standalone signal generator which could provide different waveforms and very high frequencies, but anyway, this device seems to be of very good quality and accuracy. Now let's see some audio frequencies generated by PC software in order to check FFT function. 440 Hz, 440 Hz, so not bad. Thousand Hertz, so sine wave, 1000 Hertz, 2000 Hertz, so it's okay for PC software. Now let's turn the FFT function on. Log. We can see here this red line. FFT linear only here, two kilohertz. It moved a bit to the right, 5 kilohertz, also moved to the right. As to music and music. So sometimes this function can be really useful in case of audio monitoring. As to the conclusions, the device is really very tiny. It can be called a pocket oscilloscope. According to the supplier, the maximum frequency of the oscilloscope amounts to 120 MHz, and the maximum frequency of the signal generator amounts to 2 MHz. The device has 2.4-inch display and also the protection of soft silicone case. As to the additional advantages, it's very easy to use it, and also you have no need of additional devices in case of checking of mains voltage. Thanks for watching. Wish you good luck.